Hello friends, and welcome back to Trick Equals Treat, where we turn tough math problems into epic brain adventures. Today, we've got a classic duel, comparing two numbers that look totally different. Our contestants are contestant A. This guy is a combo. It's 1 plus square root of 10. Contestant B. The sleek single-term number, square root of 17. To figure out who's greater, we can't just guess. Of course, we can use calculators, but that siphons off all the funny math. But dealing with those messy square roots is always tough, so what's our first move? We're going to use the ultimate simplification trick, squaring them both. The apparent thing is A and B are both greater than 0. Think of it like this. If A is bigger than B, then A squared must be bigger than B squared. This is valid since both A and B are positive. Let's start with A. When we square A equals 1 plus square root of 10, we get A squared equals the square of the sum of 1 and square root of 10. Remember your algebra? The classic, the square of the sum of x and y formula. 1 squared equals 1. 2 times 1 times square root of 10 equals 2 square root of 10. The square of the square root of 10 equals 10. Putting it all together, A squared equals 11 plus 2 square root of 10. Now for B equals square root of 17. This is a piece of cake. The square root and the square cancel each other out. B squared equals the square root of 17. B squared equals 17. Now we come to the final showdown. A squared versus B squared. We've simplified our mystery into comparing two new numbers. A squared equals 11 plus 2 square root of 10. B squared equals 17. Let's ask the question, is 11 plus 2 square root of 10 greater than, less than, or equal to 17? To figure that out, let's isolate the tricky term, 2 square root of 10. We'll subtract 11 from both sides of the comparison. Is 2 square root of 10 greater than, less than, or equal to 6? Divide each side by 2. The question turns to, is square root of 10 greater than 3? This is so much cleaner. So we're comparing square root of 10 and 3. Again, this is comparing a square root and a number. We have to square them both. 10 is clearly greater than 9. We can trace it back to the start. We come to the conclusion 11 plus 2 square root of 10, A squared, is greater than 17, B squared. And the winner of the duel is A. A is greater than B. Our first method was great, but it involved a lot of algebra and squaring things. Now let's look at the problem geometrically by building right triangles. This is the ultimate trick equals treat solution. A super cool outside-the-box treat. Some cool funs. Remember your geometry? Remember the Pythagorean theorem? Leg 1 squared plus leg 2 squared equals hypotenuse squared. Notice this. 10 equals 3 squared plus 1 squared. 17 equals 4 squared plus 1 squared. These numbers, square root of 10 and square root of 17, are actually the hypotenuses of two different right triangles. This opens up a whole new way of comparison, using lines and shapes, not just algebra. Let's visualize square root of 10. Now for square root of 10, we want to make it the hypotenuse of a right triangle. Now let's draw such a triangle, ABC. We first draw a vertical line segment AC. Then draw a horizontal line segment AB. Let the length of AC be 1. let the length of AB be 3. Now, the Pythagorean theorem. BC squared equals AB squared plus AC squared. That is, BC squared equals 3 squared plus 1 squared equals 10. This means BC equals square root of 10 is the hypotenuse of a right triangle with legs of lengths 3 and 1. Okay, now we can get a line segment whose length is precisely square root of 10. How can we draw a line segment whose length is square root of 17? Now, let's go back to 17 equals 4 squared plus 1 squared. We can get a line segment with a length of square root of 17 by drawing a right triangle with legs 4 and 1. Now, we already have a triangle ABC whose side AB has a length of 3. Now, we extend AB to point D, making the length of BD 1. Connect point C and point D. We now have a right triangle, ADC. The hypotenuse of this right triangle is CD. Now let's figure out the length of CD using Pythagorean theorem. At last, its length is square root of 17 equals square root of the sum of 4 squared and 1 squared. Now let's look at the triangle BCD. The length of its 3 sides are square root of 10, 1 square root of 17. Remember Triangle Inequality Theorem. The sum of the lengths of any 2 sides of a triangle must be greater than the length of the third side. Here, the sum of the length of 2 sides is 1 plus square root of 10. The length of the third side is square root of 17. A, being the sum of the length of 2 sides, 1 plus square root of 10, is greater than B, square root of 17, being the length of the third side. That's it, a stunning geometric proof that avoided all the double squaring and gave us the answer without eyes. Which method do you like best? The direct algebraic dual or the subtle geometric trick? Let me know.